All right, we are looking at another optimization problem here. Let's go ahead and read it, see what we can do with it. It says, from a thin piece of cardboard, 50 inches by 50 inches, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume? And then round to the nearest tenth if necessary. So we've got a couple of questions we're answering here. Number one, dimensions of the box. And then what is the maximum volume? All right. So what I'm going to do is I'm going to draw a picture. All right. Now here is, and not that color. Let's pick this color, blue. All right. Here is this box, a rectangular piece of cardboard. And it says that they're going to cut out squares. So if I cut out a square, and I'm not the best artist here, and I don't claim to be one, and I don't know why my colors are not changing, but let's pick this square here. All right, and we're going to assume that all of these are the same, so don't pay any attention if my drawing is not to scale. But we're going to cut out a square of, suppose, side length x on each of these. All right, so I'm just going to go around and I'm going to call it X there all over. Now, I know that the dimensions of the full figure are going to be 50 inches. All right, 50 inches. The length and the width are 50 inches. All right. So what I'm going to do is I'm going to now come up with some equation that models the volume. Well, I know that volume equals length times width times height. All right, volume equals length times width times height. Okay, so now because of that, I try to figure out, well, what is the length? What is the width? What is the height? And so I'm going to say my length is going to be, in this case, it's this here at the bottom. It's 50 inches, but then you've got to subtract this portion here and this portion here. Well, each portion is x units. So it's going to be 50 minus 2x. All right, that's the length. Now let's consider the width. Let's say this is the width. All right, well, it's 50, but then we got to cut off this portion here and this portion here. So the width is going to be 50 minus 2x. All right, now if you were to fold up these flaps, how tall would it be? Well, the height is going to be x units. So the height we shall call x. Now, we're getting closer to the equation, and that is to say that v equal, and it's going to be length times width times height, which is just 50 minus 2x quantity squared times x. Okay? And this right here we're going to want to expand. And so you're going to have to do the FOIL method, if you will, or you could do a binomial squared trick. But I'll just go ahead and write it out, and you'll have to figure that one out. If you don't know, go and look at one of my other videos for special products or something like that. All right, it looks something like this. And actually, it's not 12x squared. I'm sorry. It's 4x squared. All right, should be 2500 minus... And it's not. I don't know what I'm thinking here. I'm jumping the gun. It's 200x. All right. 2500 minus 200x plus 4x squared, all multiplied by x. And so then I'm going to distribute the x across the board. And v equals 2500x minus 200x squared plus 4x cubed. And so now I'm going to find the derivative because I need to optimize this. And so I find v prime is equal to 2500 minus 400x plus 12x squared. There's the 12. I was jumping the gun earlier. All right. Now what I need to do is I need to try to solve this by getting this equal to 0. What I'm going to do is I'm going to divide out the greatest common factor, which in this case I believe is 4. All right. And I end up with something like 625 minus 100x plus 3x squared. I could try to factor it, but I'm just going to use a quadratic formula. It's a little bit easier in this case, ABC, right? And so I say opposite B, which is negative of negative 100. Opposite B plus and minus the square root of B square, which is negative 100. And let me fix that a little bit. It's not too nice of handwriting here. Negative 100 square minus 4 times 3 times 625. Should look like that. All divided by 2a, which is 2 times 3. Okay, not too bad. So I end up with positive 100 plus and minus. I get the square root of, let's see, what is that? 10,000. And then 4 times 3 times 6, 25 is 7,500. All divided by 6. And I end up with 100 plus and minus, let's see, fix that. 100 plus and minus the square root of 2,500, all divided by 6, which gives me 100 plus and minus 50 divided by 6, which gives me two options. I either have 150 over 6 or 50 over 6. All right, well, what does this one equal? In the first case, 150 over 6 is 25. And this 50 over 6 is about 8.33, right? 8.33 repeating, so 8.3. So when I do my wiggle graph for V prime, I have to compare 8.33, or actually let me just put 8.3 because it did say round to the nearest tenth. 8.3, fix that a little bit. And 25. And what we're going to do is we're going to plug in numbers into our V prime formula, which this is V prime right here. Let me erase that. Okay, come on now. There's my highlighter. I'm going to plug in numbers in here. All right, but I've already taken kind of the guesswork out of that for you. You can pick numbers before 8.3, after, and in between and after 25. But this is what ends up happening. You end up having positives here, negatives here, positives here. All right, so if it goes from positive to negative, of course it is a maximum. And if it goes from negative to positive, of course it is a minimum. So this is how we determine which value to accept. Let's go back to our question. They wanted us to maximize the volume. All right, maximum volume. So in that case, I'm going to need to use the 8.3 right there in place of x, which is the height. Okay, so if the height then is 8.3 units, and in this case it's actually inches, then I'm going to back substitute that into my L equation up here at the top. And so I'm going to say then L equals 50 minus 2 times 8.3. All right, so what does that end up being? Something like this, 33.3. Okay, and then the same thing actually happens for the width. It's actually the same exact calculation. All right, so then we have these two values here. All right, and it's probably 33.4, but we'll just leave it at that. All right, and so we've got the length is 33.3 inches. The width is 33.3 inches. And so this is our answer. This is part of our answer anyway. But now we need to also state the volume. And so what I'm going to do to find the volume is I just multiply those three numbers. I get something that looks like this, 9203.8 inches cubed. Okay, so these are my values for my length, my width, my height, and the maximal volume for the problem. All right, so maybe it was a little bit involved here, but otherwise it's generally okay. Remember, draw the picture. relate the variables, take the derivative, apply the first derivative test, and then see which one gives you your minimum or your maximum, whatever it is you're trying to optimize here. All right. As always, I hope this video was helpful, and remember, like and subscribe.